Hello and welcome everybody to math class. Take your seats, make sure you have that stuff over there, something to write on, something to write with, your multiplication table if you made one from yesterday, or access to our online multiplication table available through the virtual classroom. Today, right above my head, here's our teaching point for the day. We're going to be finding common denominators. We've been doing a lot of kind of our preparation work in regards to fractions. And a lot of it has been around how to use equivalents of 1 and the concept of using an equivalent of 1 or multiplying, dividing by 1 that doesn't change the value. Using those equivalents of 1 to change our denominator without changing the value of our fraction. Okay? We did a lot of this prep work because we're going to be getting into adding and subtracting fractions with unlike denominators. So if we have something like behind me, I'll make it bigger in just a second, but 1/2, let's say plus 1/5, or 1/2 minus 1/5, right? We can't do that math just yet because our halves and our fifths are different sizes. If we think about a fraction as a unit of measurement, we have to make sure if we're going to add or subtract two measurements together that they're the same size measurement, that we're using a common measurement or a common size. In this case, a common denominator. And we can use our good friend the multiplication table to help find those common denominators. Our teaching point, our I can down below, says this: I can use a multiplication table to find a denominator common to two different fractions. Let's get into it with this first idea here. 1/2 and 1/5. Now, these fractions are different sizes, right? A half being our fraction bar, our 1 fraction bar, cut into 2 equal pieces. Again, same value of the whole thing, but now we've cut it into 5 equal pieces. In order to add or subtract them, we have to make and figure out what size pieces can I split each of these into to make them equal sized. Okay? And we can do that with our multiplication table. If we take, again, I'm going to take I'll use Jaslea's today. If we take something flat or something straight to keep our attention, and we come over here for this, and we look in the 2's row, our multiples of 2. And then we're going to look in our 5's row, our multiples of 5. And we want to know, are there any numbers that show up in both rows? So let's look at our 2's here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay? And then let's look at our 5's row. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. There were a couple of common numbers in there, weren't there? The first one I got to, and I remember, is that 10. I can see it right there in our 2's column, our multiples of 2. I see it in our 5's column, our multiples of 5. That tells me it is a common multiple. 10 is a common multiple. So we have tenths, or tenths, would be a multiple common to both our halves and our fifths. We could cut this half, each of these halves, into 5 equal pieces. And we could cut each of these fifths into 2 equal pieces. And what we end up with are, I'll zoom in here, what we end up with are 10 equal pieces, or tenths. So we've cut both of these fractions into tenths. Okay, so tenths would be our common multiple here. There are other common multiples. For instance, I saw 20 and 20. So could we cut both of these into 20ths? Certainly could. In fact, at this point, we would just cut each tenth in half. However, to make our lives easier, we're going to look for the common multiple with the least value, because 10 is less than 20. It's going to be a little bit easier for us to work with. We don't have to think about cutting these into so many pieces. We don't have to multiply these fractions by a very large equivalent of 1. Okay? We want to keep our pieces as large as possible, and we want to keep our denominators as small as possible. Make sense? So just for today, because we're not going to be adding or subtracting these today, all we want to know is, and what you're going to be expected to show on your exit ticket is, what is a common multiple, ideally the least common multiple, of the two given fractions. So if you have halves and fifths, what's the number that shows up in both rows that has the least value? In this case, it would be tenths. Okay, let's try one more on the board before we go to the digital whiteboard. Let's think about something like if you had two fractions like 3/4 and 1/6. What would be a common multiple of those two fractions? Let's look at our 4s. We got 4, 8, 12, 16, 20. Are any of those numbers in the 6th row? 4, 8, 12, 16, 20. Yeah, 12. Right there. Okay, so for today, our answer can be, we can put 12ths or 12ths. That's a lot of consonants in a row. Okay? Because what we can do, and today we're actually not going to worry about how many 12ths would each of these be. So not worried about that. Okay? All I want to know is, what is a common multiple between these two denominators? In this case, 12 shows up both in the 4's row and in the 6's row. Are there other common multiples between 4 and 6? Sure, like 24 I see as one, right? Especially because that's 4 times 6 all by itself, right? Additionally, like 36 shows up in both rows. 48 shows up in both rows. Okay, so all of those are common multiples. You can divide 48 by both 4 and 6 and it'll come out even. There won't be a remainder. In this case, we want the least common multiple, okay, which in this case is 12 because it's the lowest number, the number with the least value to show up in both rows. Okay, we're going to move to our digital whiteboard now. If you have your multiplication chart, multiplication table that you made yesterday, now's a good time to have it out. Or if you have your name tag at home with your multiplication table on it, now's a good time to use it. Or you can go to the interactive multiplication chart as well. The sort of most sort of advanced level of this would be being able to do it without a chart and just thinking about, okay, what are my multiples of 3? What are my multiples of, in this case, 5? And what's the least common multiple? What's the common multiple with the lowest value? So let's start by, in this case, because we have thirds and we have fifths, let's list out our multiples of 3 and our multiples of 5. So we have our 3's row would be 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. And so on. If we don't find one smaller than 21, then we'll add some more. And then here's our multiples of 5. 5 times 2 is 10. 5 times 3 is 15. Oh! Got it. So our least common multiple, put LCM, equals 15th. Well, our least common multiple is 15, so we're in 15ths. And here's how you spell 15ths. It's just 15 with a THS at the end. 15ths. Okay? Well, I'm not even interested in how many 15ths these fractions are. That'll be Thursday. Okay? Because we are going to start kind of adding them together on Thursday. So on Thursday, you'll need to know how many 15ths there are, and we'll go over that on Thursday. But today, we're just practicing what denominator am I going to need. All right, here we go. 1/4 and 3/10. Go ahead and list your 4s, and then list your 10s. Let's start with the larger fraction this time. Or start with the larger denominator this time. So we'll start with 10. 10 times 2 is 20. 10 times 3 is 30. 10 times 4 is 40. Wait a minute. Okay, I already know. I see my 40. I already know that's 4 10s, or 4 times 10. So I know 40 is going to be a common multiple between 4 and 10. So I'm going to stop there, because I know at the most it's going to be 40. So let's list our 4s and see if 10, 20, or 30 show up. 4. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. Aha! There's our least common multiple. We would be in, we're going to make these fractions 20ths. You change that y to an IE when you're making it 20ths. Okay? Making a little bit more sense here. Let's try a couple more, and I'm going to give you less help. Let's try this one. 4/9 or 5/6. 4/9 and 5/6. So go ahead and list out or look at your 9s row in your multiplication table, and look at your 6s row in a multiplication table. Which numbers show up in both? Which numbers are in common between the multiples of 9 and the multiples of 6? I'm calling it the least common multiple because not that it's least common like most uncommon, but that it's the common multiple with the least value. That's why. Good question. If you think about a multiple as any number that when you multiply one number by another, for instance, with the multiples of 9, you multiply 9 by anything, you're going to get a multiple of 9. Any whole number, you're going to get a multiple of 9. So let's list our 9s here. 9. Oops, changed to the blue pen for consistency's sake. 9. 9 plus 9 is 18. 18 plus 9 is 27. 27 plus 9 is 36. Oh, we got a 36 in the chat, so I'm going to stop at 36. And I think I would agree, because definitely 6 times 6 is 36. So I know that one's going to be a multiple, but is there a multiple that has less value? Let's see, 6. 6 plus 6 is 12. 12 plus 6 is 18. 18 and 18. Oh, here we go. Okay, so we would call, even though I would definitely agree if we kept going to 24, 30, 36. We're going to get another common multiple there, right? But since 18 has less value, is a lower number, we're going to want to use 1/18ths, just because it's going to be a little bit easier to handle once we get into turning these fractions into 1/18ths. Okay, so once we get into converting 4/9 into a group of 1/18ths, and then converting 5/6 into a group of 1/18ths, that's going to be a little bit easier to handle, a little bit smaller numbers than converting it into 36ths. And often, if you convert it into 36ths, then you'll have to simplify it back later. So it's an extra step that we can avoid if we use the least common multiple, the common multiple with the least value. Alani says, yes, 54ths would also be a common multiple of 9 and of 6. An easy way to definitely and definitively find a multiple is to actually multiply these two together. 9 times 6 and 6 times 9 is going to get 54. So if you're ever in a pinch, when in doubt, you can always multiply them together. However, in this case, since there's a smaller number we can use, we're going to go ahead and use it. Okay, last one. I'll let you try this on your own before we get out of here. 1/2 or 3 or and 3/8. What is a common multiple of those two? And this one's not quite a trick, but it is a little handy because the least common multiple already exists in one of these fractions. Because we've got, if we count out our 8s, 8, 16, 24, 32. One thing I'm noticing about these is that all of them, 8, 16, 24, 32, they're all even numbers. So they're all multiples of 2. Now, let's go 2, 4, 6, 8. So we're going to use 1/8ths as our least common multiple, which we're already in 3/8. Okay, I see some 4s in the chat. The reason why 4s don't work, let's look at this fraction of 3/8. If we want to change our 1/8ths into 4ths, we have to divide by what? 8 divided by what equals 4? We have to divide by 2, right? Because 8 divided by 2 equals 4, or 8/2 equals 4. But can we divide 3 by 2 equally? No, right? Because we'll end up with 1 remainder 1, or 1.5. And we can't have fractions inside fractions, like 1.5 fourths is not proper formatting there. So we need to use 1/8ths. Okay? If, let's say, as an example, if we had something like 1/2 or 6/4, or 6/8, I mean, sorry, 1/2 and 6/8, I could use 4 because 6/8 is equal to 3/4 if we simplify it by dividing by 2 over 2. Okay, because they're both even, we can cut them both in half and they will still have whole numbers top and bottom. Okay, so in this case, 4ths would be okay. But in this case down here, we're going to want to use 1/8ths. Makes sense? All right, everybody. Math Group B, we will see you in the Zoom room in about 10 minutes or so. Additionally, if you want a little extra practice on this, come on in. Do the exit ticket. If you have questions on the exit ticket, come into the small group. There have been a number of people who just pop in for like a quick, I'm not sure about the fourth one on the exit ticket. Can we go over it together? Right? Makes complete sense. All right? So, good luck. Turn in that exit ticket. Come to the Zoom room if you have questions. We will see you back here at 12:30 for our writing lesson of the day. Cheers. Good luck.